Hi everyone, this is Amir Mohammad Shahsavarani. Thank you for continuing this course with me. We are in the course Algorithm in Computer Science and we are in session 5 in which we start pseudocodes. And I've titled this session part 1 because I think we may have some 3 or more sessions in pseudocodes topics, and we wanna go deep inside the pseudocodes. But don't worry, I try myself to keep everything simple. Okay, first of all, I think we would better speak about the definition of pseudocodes. Pseudocodes are some way to express the logic and flow of a program or algorithm using natural language like statements. When we speak about natural language like statements, we just mean about some, you know, higher level languages in computer programming. Pseudocodes are used to describe the steps involved in solving a problem or performing a computation in our procedure of developing and programming in computer science. Pseudocodes are mostly often used as an intermediate step between the initial idea and the actual implementation of the code. So, better saying, a pseudocode is a high-level representation of a program or algorithm written in a natural language-like style, and then pseudocode uses simple statements to describe the logic and flow of the program without including actual programming codes. Just simple statements like our speaking languages. Good. Some applications for pseudocodes. First of all, I think one of the most known applications for pseudocodes, simplifying complex concepts. Pseudocodes can help simplify complex algorithms and data structures by breaking them down into smaller, more manageable steps. You can see it in just a few slides afterwards. Second, improving communication. Pseudocodes can help us and could be used to communicate ideas and concepts between developers, team members, or even with non-technical stakeholders. For example, you do have some project manager, an investor maybe. Another application would be faster development. Uh, I mean that by providing a clear outline of the logic and flow of an algorithm, pseudocodes can help developers implement these codes more quickly and accurately. So these are the benefits I have searched, and I thought maybe these would the most beneficial and credential issues for pseudocodes. Good. Let's keep these theoretical issues smaller as possible. Running to some examples of pseudocodes. In this session, I'm just showing you the examples, and from the next session on, we would exactly go through them step by step, learning how to make pseudocodes from the beginning, from the simplest to the hardest. Don't worry. First of all, our first example of pseudocode would be something like this. Simple algorithm for finding the maximum value in an array. We do have some array and we want to find some simple algorithm to do so. The problem: write a pseudocode to find the maximum value in an array. So the definition would be the algorithm should iterate through the array, comparing each element to the current maximum. If it finds a larger value, it updates the maximum. So simple. Okay, how we can write it in pseudocode? In pseudocode, first we make some max value. For example, it's not important, just we want to set some value, name with max value. Okay, it's array 0, for example. Then from for I, from 1 to array dot length minus 1. Why minus 1? Because in computer science we start from 0. So if we do have 10 members in some array, some given array, we actually have 0 to 9. For I, from 1 to array dot length minus 1, so on. If the item in that array is greater than max value, then set the max value into that item. As you have seen, first we have set it to 0, then we are just checking. This algorithm goes through all the array so that finds the maximum and the greatest size of each of the array members. Then afterwards return max value. Just see that we do have input, we do have the process, we do have the return phase. These 3 phases. Okay, so our next example, our second example consists of algorithm for storing a list of number. List store algorithm, we can say. So the problem is write a pseudocode to store a list of numbers. And the definition would be that algorithm should repeatedly iterate through the list, swapping adjacent elements if they are in the wrong order. Okay, making the order. So as you may know, we have 2 storing systems, ascending and descending. Just keep it simple. No matter where you go and how you make it, just make some sort like this. Good? Okay? How to write it? First, make some iterator. For I, from 0 to list that length minus 1, as I've told you in previous example, because the list is starting from 0 to blah blah blah, we do have some minus 1. For each item, for j, from I plus 1 to list that len minus 1, we make if the I is greater than j. As you can see, it's a sort of binary comparing 2 by 2. Just we do have one I and we do have one j. As you can see, I is from 0 and list that length minus 1. J is I plus 1. It means that j is someplace one step further than I. If I greater than j, then swap list and list j. Okay, make the j further or everything that would be in your mind. Then return our list. So these algorithms just going through our list comparing 2 by 2 and just sorting everything with its previous one or its next one. Good? Okay. As you have seen, we don't have here any type of complex programming or codes, just higher language, just our language, human language. Okay. Our third example, algorithm for searching a binary tree. We do explain these issues of concern in our data structure course. But if you have remembered it from our session 1, we have spoken about binary trees, so briefly. When we do have some binary tree, we mean that we do have a tree which has each node, in which each node has two wings, two childs, as you can say, or maybe two leaves, you can say, but leaves are the endpoints. But if we do have some branches, so each node has two branches and two childs. Good. Problem: write a pseudocode to search for a value in a binary tree. Definition: the algorithm should start at the root node, then recursively moves down the tree comparing values until it finds the target value or reaches a leaf node, as I told you. So, how can we write it? First, we make some current node, set current node tree.root. We are starting from root. Good. We shall make some while loop. You have may learned about it in our object-oriented programming course, or you may have seen it in C# course. If not, you can just go there and see those videos. Don't worry about it. So we say while, I mean until the time our current node is not null. German people call it null or null. We do mean that it's not empty. Okay. If the target value equals this type of writing shows the two strings, and we just mean that the values are equal to each other, not setting a value for some variable. If our target value equals to our current value, okay, then return current node as our result. But else after this if our target value is less than current node value, so set current node as current node.left child. Okay? Else we have just made the left. In binary code searching, we going from left to right in order to understand all, and explaining all the three. Else set our current node to current node.right child. Okay? So here we showing, and we are just putting our left child, but we are now setting our right child. Then, afterwards, it just checks. While it's not null or null, we are just coming downwards. First checking that current value is our target value. Okay, this is okay. If not, left, right, again. This is while loop. I mean that we do recursively run this second step. This step is called our process. Okay? Until we reach the point that current node is null. Okay. Then, if everything is checked and we have inspected all the nodes, return null, that means we have not found what we have searched for. Good. I think maybe these examples are to some extent hard. First of all, but I've just wanted to show you that some issues like binary search, in binary trees are so simple to be made as some pseudocode. Our fourth example. In our fourth example of pseudocodes, we do have algorithm for finding the middle element of a linked list. So, for this, our problem is to write a pseudocode to find the middle element of a linked list. So, defining it would be the algorithm should iterate through the list, counting the numbers of elements and finding the middle, the point that half of the list is at right, half of the list is at the left or top and bottom. I don't know what you think, but just the middle point. That's so simple. Good. Our pseudocode. First, we shall make a sort of counter for it, so we can set counter to 0. Then we can set some node. Our current node is list head. Okay. We make some loops. We make some while loop. While current node, our current position is not null or null or null. Increment the count. Count goes upward. Then set our current node to current node next, which means that we shall go some place forward one step by another in our list, in our network or everything else. And then this while loop goes until our current node becomes null. At last, our output return giving back list.head. List.head is set current node plus count divided by 2. It's half of the count. Okay? List.head plus this would give us our middle element. So simple. You can maybe do all these issues on your own way. Don't worry about it. I'm just showing you some possible ways. These are not exactly, determined, and I can say you like your fingerprints, your coding, and your pseudocoding is unique. Our fifth example of pseudocoding. Some algorithm for calculating the area of a rectangle. In order to do so, we shall write a pseudocode to calculate the area of a rectangle. How? The algorithm should multiply the length and width of some given rectangle. So, how does it work? First, so simple. We set some issue named area, which equals the length multiplied into width, and second, return the area. As you can see, don't worry about everything. Everything is possible. So simple. Our next example, algorithm for finding the first duplicate in an array. First issue that is being duplicated in our array. Write a pseudocode to find the first duplicate in an array. Defining it would be the algorithm should iterate through the array, keeping track of the elements it has seen so far. Having the track of elements and see if it has been duplicated. Good. First, we make some array. We make some set. That we set a set named scene and its array. Okay. Then we say for item from 0 to array dot length -1, which I've told you why, because it's starting from 0 and in real world we count from 1 2 3 4, but in our computer world we count from 0 1 2 3, just 4 places. If our item in scene, we just return that our duplicate is the I. Okay? Else, just add these I item to our scene list and go forward. Okay? Then, at last, return null if no duplicates were found in our list. This is so important to communicate with the code. Good. Our seventh example comprise algorithm for calculating the average of a set of numbers. So, write a pseudocode to calculate the average of a set of numbers. Calculating all the numbers in our set. The definition is the algorithm should sum up all the numbers and then divide by the count, because we wanna have the average. Good. What shall we do? First, we shall make some variable named total and set it to 0. Then we shall make some variable named count and put it to 0. Okay? It's our total. We don't know how much issues, how much numbers we do have in our set. Okay? Because of this, we put 0. And because it's summation, in summing up, we can give a 0 to the variable, but if we are just multiplying or dividing, we shall put 1 in it. So set count, we don't know how much we do have in our list. Okay. 3. For I from 0 to list that length -1, add items in the list to the total. So this total is sum up of the all issues. Then increment count, adding up to the count. For example, I've just seen 7. I'm the algorithm and I'm just going to the set. I'm just seeing the first number 7. Okay. I'm just adding 7 to this 0 would be 0, and increment the count would be 1. Okay. It's doing all the list and going upward until the end, and then at last return total divided to count would be average. But in our real world programming, that total divided to count is not fair enough to be put in our return of any sort of class, and we shall make, for example, some other line to it that we make some average equals total divided to count, and then returning the average. This is much more safer, and they call it clean code. Good. Our eighth example, algorithm for finding the shortest path in a graph. As you may remember, some algorithms are divided to graphs. So write a pseudocode to find the shortest path between two nodes in a graph. When we do speak about graphs are different from trees in their order issues. And if you just search it, you can find it, or you can go to our data structure course and see everything there. Good. The definition of our pseudocode within the algorithm should use a priority queue to keep track of the nodes to visit, starting from the start node. So this is something we can say a little complex. Don't worry, because these sorts of algorithms and pseudocodes mostly being used in AI issues, and when you deal with some algorithms like this, please believe me, you are at the state of understanding it fully. So don't worry. Okay. Our steps: first, we make a queue, and we just give it a value of start node. Then we make some while loop. While loop works until our condition is not met. While queue is not empty, our queue is the start node and it's working. It's not empty. Okay. The queue, next node from the queue. Okay. Then, if our next node equals to target node, returns pass from start to next node plus next node. Okay. Then we say else. We do mean another condition. If is our first mode, our second mode, if not this mode, for neighbor in next node that neighbors, we made enqueue neighbor into our queue. Then at the final stage, while works until queue is become empty, then return no path found. What does it mean? We didn't find the path. We didn't find the desired path. Okay. So what shall we be done if we haven't found it? We shall report it. So it's so simple. Not simple at the first moment and first exposure, but believe me, after a while, after some facing and some interacting with these sorts of algorithms, you will better understand, and they are so safer for you, your mind. Another example would be some algorithm for finding the minimum value in a set of numbers. I think you would remember that we had some algorithm to find a maximum value in a set of numbers. This is the minimum number. Good. First, write a pseudocode to find the minimum value in a set of numbers. And defining it would be the algorithm should iterate through the numbers, keeping track of the smallest one. So it's a sort of binary search. We'll say first, set our minimum value or mean value into a list that has nothing but 0. Then we make a for loop for item from 1 to list dot length. minus 1. If this item in the list is less than min value, then set this item of the list as min value, okay, in place of this. Then going through until the end and return our minimum value here. Good. Our 10th, our last example of pseudocode would be an algorithm for calculating the sum of a set of numbers, just sum. Problem, write a pseudocode to calculate the sum of a set of numbers. Good. Definition, the algorithm should iterate through the numbers, adding them up. We just need the total here. It's some step before making average. I think 2 steps less. So what? First, we make some total variable and equalize it to 0. Then we make some for loop for items from 0 to list dot length minus 1. Add the item in the list to total. Okay. Then after doing all this, all the elements in our list, all the items in our list, return the total, and it's done. Okay, guys. Okay, everyone. I think these confrontations are necessary so that you understand we can make so much complex codes and ideas into pseudocodes. And believe me, we would learn how to do it. Don't worry about some complex issues you've seen here, because these are so regular in your coding life afterwards. Okay? In our next sessions, we're going through these pseudocoding issues. We're starting from tip to top, and we are just make everything verbatim, step by step, so that you would be able to make your algorithms. Thank you joining us. Thank you coming with us. We'll see you in our next session. Bye for now.